Lesson 42 is finding permutations and combinations. There's a difference between the two, but first let's go over a little bit of vocabulary. Whenever you see this, some number to an exclamation point, that's not math screaming at you. That is a factorial. So this exclamation point is called factorial. Okay, factorial is spelled I-A-L. There we go. So the exclamation point is factorial. That's what that means. Okay, there is a button in your calculator. If you have a calculator on you, I will show you where that's at now. So turn it on, obviously. Clear that out. Math. And it should be in probability, PRB. It's number 4 on my calculator. Okay, you see it? Now let me explain what that means. If I have, let's say, 4 factorial. Okay, 4 factorial means 4 times 3 times 2 times 1. Basically, it's itself being multiplied in descending order. Okay, if there's 100 factorial, you would take 100 times 99, 98, 97, 96, all the way down to 1. Now, yeah, it'll make it easier so that you don't actually have to do that. So, why is multiplying by 1 useless? Because it's always times itself. So, even though you do go all the way down to 1, if you ever have to write it out, you do not need to write the multiply by 1.
How do you do it in your calculator? I did the one, I had 100.
So if I wanted to do this, 100 factorial, I'd go 100 math over to probability, and I press factorial. Yeah, because it's like a huge number.
Oh, okay. So it would be just 7.
Try 7, yeah. 7 would be a reasonable number.
Wait, how did you get that?
How to get what?
How did you do 4? 5,000.
4 times 3 is?
Oh,
And 12 times 2? Okay, so it is a neat function that will allow you to do this. What is really good about it is when we're trying to find probability is when it helps us. Okay, where I told y'all guys that what was my example? Sonic was my example. That crazy number of combinations they have. They use this formula to find that number, the combination formula to find that number. Okay. Also, when you look at the chances of you winning the lottery and all of the different combinations that you can pick for winning the lottery, uses this formula to determine those odds.
Oh.
It's a big number, but it's not that big of a number.
Maybe they have a big.
I'm sure they do. Okay, so let's talk about what each of these mean. So the formula that they give in the book is a really complicated looking formula. So just put the example in there, okay? If you want to put 2 examples in there, use 5. 5 times 4 times 3 times 2 times 1. Okay? Let's just start with what factorial will look like. Example 1a. It says 5 factorial, so if I do 5 factorial, it's 5 times 4 times 3 times 2 times 1. You can type that in your calculator, or you can just go ahead and do it. It should be 120. Okay? So expanded, if it says expand then solve, you need to make sure you write it out. 5 times 4 times 3 times 2 times 1, and then give the answer.
Yeah, the 1.
Yeah, if it says expand it, go ahead and put the 1. I need to know that you understand what it really means. Later on, when we start going over these and how to do them by hand, it will be less confusing if we don't put the 1. On B, now this one gets, they go from like, oh, here's 5 factorial to solve this crazy thing really quickly, okay? So they have 10 factorial over 2 factorial, which is kind of silly, and then 10 minus 2 in parentheses factorial. Okay, so let's expand this. So it looks like 10 times 9 times 8 times 7 times 6, 5, 4, 3, 2, 1. Okay, and I'm not going to put the 1 because, again, that one's useless. Okay, I'm not going to put the 1 on this one because I'm going to solve this here in a second. 2 factorial is what?
2.
2. So I'm just going to write down the 2. I'm going to put it at the end. And then 10 minus 2 is 8. So 8 factorial is 8 times 7 times 6 times 5 times 4 times 3 times 2, and then at the end we still have that multiply by 2. So this is it, what it looks like expanded. Now this problem gets a whole lot easier because look, 8's cancel, 7, 6, 5, 4, 3, 2, and then I have another 2 up here. I'm going to go ahead and reduce the 10 down to a 5. What's 5 times 9?
45.
So the answer is just 45. Okay, yes, you can type this into your calculator, because somebody is going to ask me, I know they were. It's 10 factorial, so math probability factorial, divided by, and then you have to put it all in parentheses, okay? 2 factorial, I'm not going to type in 2 factorial, it's just 2, okay? Multiplied by 8 factorial, and then I close, wherever that's at, my parentheses, press enter, 45, okay?
Oh, okay.
You still need to know how to expand those. Okay, if, I'm going to give you another example, okay? I'm going to do a smaller one though. If we had 7 factorial over, let's say 3 factorial with a parenthesis of 7 minus 3 factorial. If it looked like this, I want to show you what it would look like if I did this the easier way. Okay, so I still have 3 factorial here. I'm going to leave that at the end. 7 minus 3 is 4 factorial. So what I would do to shorten the amount of stuff that I have to write, I would expand my 7 factorial all the way down to the biggest number I see on the bottom. So it'd be 7 times 6 times 5, and then I just write 4 factorial. Because I have a 4 factorial already, that would eliminate the 4 factorial. Okay, I wouldn't have to write as much. However, I still have 3 factorial that needs to be rewritten. So I have 7 times 6 times 5, and then I have 3 times 2 on bottom. Okay, and when you go to solve this, if you don't want to type it in your calculator, you would literally just say, okay, 2 and 6 go into each other to make 3, 3 and 3 go into each other and they go away. 7 times 5 is 35. Okay? But again, if you have your calculator and you're comfortable with it, you can use it. But you have to have lots of practice before you decide to trust yourself on a test doing something like that. And you may be telling yourself, I'm not going to see this that much. This is the most common way you'll see factorials used. Is right here, combination. All right, permutation. Write this down on, okay, so permutations, so the formula for permutation is going to look like this. It's a probability still, okay, so it's probability of n and r. I'm going to explain what n and r are here in a second, okay? And it looks like this. The n factorial over n minus r close parenthesis factorial. Now r is normally smaller than n, okay? I've never seen the factorial of a negative number. I don't think it's possible. Don't quote me on that though. So when I see this, I read it as the permutation of n objects taking at r at a time. So if I say 6 students taken 2 at a time, I'm talking about pairs. Okay, if I said 6 students taken 2 at a time, that's how I would write this. P of n comma r. That way I know what to plug in, and then I would plug in. So if I said the permutation, so my first example, this is your formula that you need to write down. First example says permutation of 6 objects taken 3 at a time will be, and then I start plugging it in, 6 factorial over the difference of the two, 6 minus 3 factorial. And it equals 6 factorial over 6 minus 3, which is 3 factorial. Now again, I could type this into my calculator and get an answer, or I could expand it and solve it as much as I can. So it's 6 times 5 times 4 times 3 factorial over 3 factorial, and my 3 factorials cancel. So 6 times 5 times 4 gives me 120, I do believe. I heard a what? What's the question? Sure. So 6 times 5 times 4 is 120. So the overall answer is P of 6 objects taken 3 at a time equals 120. That would be my final answer. Okay? Questions? Okay. So the way that you might see this is in password combinations. Sometimes you might see that. Yeah, you can see them then too. Example 2, finding permutations. They're going to give us a couple of examples. It says find the permutation of 8 objects. Okay? So if it says find the permutation of something specific, like 8, and it wants us to find the permutation of just 8, we would take 8 and apply a factorial to it. Okay, so 8 permutated, or the permutation of 8 is 8 factorial. That's it. Type that in the calculator, it'll spit out some ginormous answer, which is like 40,320. Okay, so here it said find the permutation of 8 objects. You would just write down 40,320 possible permutations of 8 objects. Okay, now if they say find the permutation of 6 objects, find the permutation of 6 objects, taken 2 at a time, I would have to start applying this formula. So 6 factorial over the difference of 6 and 2, which is 4 factorial. And then I would need to expand it, so it's 6 times 5 times 4 factorial on top, and 4 factorial on bottom. Those cancel. I'm left with just 30. Any questions? And once again, yes, you can use your calculator to do these. Sometimes it'll take you longer to do that than it would be just to solve them, though. Alright, on C, this is the ones that most people get confused on, so let's pay extra attention here. It says find the number of distinguishable permutations of the letters in the word connection. So how many letters are in the word connection? 10? So there are 10 letters. Now, we're going to look through there and see all of the letters there. It says C is repeated 2 times, O is in there twice, N is 3 times. We have T in there just once. E was 1. Is there any other ones? Am I missing? I. Okay. So distinguishable permutations basically is just saying changing that order. Okay. So if I'm talking distinguishable permutations, I'm going to take 10 factorial because that's the total number of letters that I have available. Okay. And I'm going to divide it by the total number of options that I have. Now I'm not going to divide it by 1 because, well, that's just a waste of time. So I'm going to divide it by 2 factorial, which is just 2. O factorial, so that would just be again 2. And then 3 factorial, which would be 3 times 2. Okay? And then I would simplify it down as much as I can. I heard of what? Or not. So whatever 10 factorial is, big long number, 3,628,800, divided by 2 times 2 times 2 times 3 will give us 151,200 distinguishable permutations. Questions? I got the 2 here, I got the 2 here, and then 3 factorial is 3 times 2 times 1. So maybe I should have wrote 3 factorial expands to that right there. Does that help? Okay. Next one is combination. Combination is very similar to permutation in its setup. I would say n objects taken r at a time still, but this time our formula changes a little bit. It gives us the same basic concepts as permutation, but they add on the outside an r factorial. So like that example that we saw from before. So make sure you get that formula written down, and then we're going to start just working those problems. So combination of 5 objects taken 2 at a time is 5 factorial over 2 factorial, which is just 2. And then the difference of 5 and 2, which is 3 factorial. Okay? And then I would solve that out. If you're using your calculator, again, it's okay. I'd get 5 times 4 times 3 factorial. My 3 factorials would cancel out. 2 factorial is just 2, so I'm not going to rewrite it again. So my 3 factorials are gone, and I'm left with 5 times 4, which is 20, and 20 divided by 2 is 10. So that would be my total answer for that one. It's just 10. 10 combinations. Okay, so, yes. 2 and 3 factorial. Okay, so to decide whether you're going to use combination or permutation, you have to look at what the directions tell you. If it doesn't directly say combination or permutation in the problem, then you need to be able to distinguish between the two. So to decide if a permutation or combination is needed, ask yourself if order is important. Is order important? This is to decide whether you're going to use permutation or combination. Now, the arrangement of digits in an alarm system requires a specific order, okay? So if we're talking an alarm system, it requires a specific order. The code 352 is different from the code 335, so order there is very important. So a permutation is used. So permutation, here we go, let's do this. If it is yes, order is important, it goes down to permutation. If the answer is no, then combination. Now what's helped me get through these, permutation is permanent. That means you can't change it, you can't change the order. Combination, if you think about a combination pizza, it doesn't matter what order you put them in so long as the sauce goes down first? Not necessarily, right? No, I like cheese on top of my
You put
tacos.
cheese, meat,
Yes, yes indeed. But is it going to change how it tastes? Probably not, right? Okay, so that's what helped me. If it doesn't help you, that's fine. You can memorize yes and no. That's okay by me. Okay? Well, not really. We're going to do some examples and decide which one is which. Okay? Example 3 just goes through some more examples of how to do that. I'm not going to do those. Now on B, it says how many different pizza varieties can be created if there are possible 2 choices of crust, thick or thin, and 2 out of the 3 toppings are selected. So we got to think about this. Is that going to be a combination or is that going to be a permutation? Combination, it doesn't matter, right? So in order to solve this one, we would take a combination of 2 things. First of all, the combination of 2 types of crusts. So we have 2 crusts taken one at a time. That would be our first combination. Our second combination is to deal with the toppings. So the second combination has 3 toppings, and you are taking a combination of 2, so 2 at a time. We would just simply solve these using the combination formula. If my pencil would spit out some lead, that'd be wonderful. So we have 2 factorial over 1 factorial, which is kind of silly to say, and 2 minus 1, which is still 1 factorial. So the combinations of crust, you only have 2. So we did a really complicated formula just to say, hey, there's only 2 options on crust. Next, combination for toppings. We have 3 toppings taken 2 at a time, and the difference between the 2 is just 1, so it's 1 factorial on bottom. So it's 3 times 2 times 1, and then 2 times 1 times 1, which is just 2. Those 2's cancel out, and we get 3. Okay, so I have 3 different options of pizza toppings that I could choose from. Okay? Now, if I want to find out how many total options I have together, because I have 2 different toppings of 2 different types of crusts, and I have 3 different types of toppings that I can put together, I want to find out how many total options I have. I would just multiply them together. This is that counting principle stuff that we went over. We would just multiply those 2 together and we get 6 total options. 6 available. Okay. Yeah. The factorial of 1 is 1 times 1. Because factorial only goes down to 1. Whoops. Okay.